PolyCast is a 3D printing material designed specifically for investment metal casting. PolyCast features ash-free technology, which optimizes the material for a very clean burnout, typically leaving an ash residue of 0.003%. Following these 9 steps, it is now possible to create high-precision metal parts from 3D printed patterns in a matter of days. With no constraint on part numbers or tooling times, design iterations can be implemented at a higher rate, creating a more efficient workflow. In this video, we'll follow a short production run of 140 custom pieces with a complex geometry featuring undercuts. PolyCast is a very easy to use 3D printing material. Using regular PLA settings, with no heated bed or enclosed chamber required, you can print PolyCast on any extrusion-based 3D printer. PolyCast can also be used with Polymaker's layer-free technology, which removes the layers and creates a clean surface for investment casting. This process reduces the chance of small bubbles forming in between the layers when the parts are dipped in the ceramic slurry. Once the parts are printed and polished, they can be assembled onto a wax tree in preparation for moulding. Some additional shapes are added as a passage to direct the molten metal into the mould. These are called sprues. Other shapes are attached to the 3D printed parts to prevent cavities due to shrinkage. These are called risers. The tree can now travel to the dipping station, where it is submerged in ceramic slurry. This is then showered with a fine silica compound and left to dry before the process is repeated and a sufficient wall has formed around the PolyCast prints. The moulds are then transferred to the kiln for the curing and burnout process. The moulds are placed upside down in the kiln at a temperature of 900 degrees centigrade. This fires the ceramic and cures it ready for moulding. The PolyCast patterns are completely vaporized during this phase, leaving a clean investment mould. For highly detailed parts, the moulds can then be rinsed to wash away any residual ash, and the inside surface of the mould can be inspected before casting. However, this step is not always necessary. Foundry workers heat stainless steel in an induction furnace and remove any dross or impurities from the surface. The reheated moulds are then transferred from the kiln to the casting station, where the molten stainless steel is poured into the investment moulds. The moulds are then covered in a flux, which prevents oxidization on the surface, and the moulds are set aside to cool naturally. Once cooled, the brittle investments are shaken off with a pneumatic jack before a plasma cutter is used to remove the parts from the metal tree. The parts are now ground and inspected before they can be transferred to the final stage of production. Finally, the parts can be transferred to the CNC, where they are precision milled to achieve the desired dimensions and tolerances. Using PolyCast to create casting patterns greatly reduces the time between CAD and metal parts, allowing quicker iterations on working prototypes. PolyCast also completely removes any need for tooling, which is time-consuming and requires large volumes of parts to become economically viable. Furthermore, 3D printing is not limited by undercuts or draft angles, allowing more complex geometric patterns to be produced. For short production runs, rapid prototyping, and intricate shapes, PolyCast offers a solution to enable your ideas.